So ramp metering is a traffic engineering idea that requires cars entering a freeway to stop for certain periods of time before joining traffic flow. The theory is that ramp metering controls the number of cars on the freeway and the number of cars accessing the freeway, resulting in a freer flow of cars, which ultimately results in faster time travel. To test whether ramp metering is effective in reducing travel times, engineers conducted an experiment in which a section of freeway and ramp meter installed on the on-ramps. The response variable for the study was the speed of the vehicles. In a random sample of 15 cars on the highway for a Monday at 6 p.m. with a ramp meter on, and a second random sample of 15 cars on a different Monday at 6 p.m. with the meter off, resulted in the following speeds in miles per hour. And so we got to click on this little table here. We've got ramp meter on, ramp meter off for 15 speeds. Draw a side-by-side box plot of each data set. Does there appear to be a difference in the speeds? Are there any outliers? Choose the appropriate box plot below. So let's go ahead and open this in StatCrunch. So click the little full data set, open in StatCrunch. Okay, so it pulls up really nice. We don't want to spend a whole lot of time typing data in if we don't have to. Let's do box plot. So graph, box plot. Select both of them. And since they did horizontal, I'm going to do horizontal. And generally that's what we're going to do unless we have a bunch of them. A lot of times it depends on our labels and how long those are. So, and we'll use fences to identify any outliers, and then just press compute. And there we go. Okay, so ramp meter's off. I mean, there's definitely, if you're looking at the box plot here, the one I just did in StatCrunch, I can hover my mouse over it and kind of get the 5-number summary, which is nice. And so we got a median of 41 when it's on, and versus a median of 37. So this is the meter on definitely has a larger median. So the only one, if I'm matching that, where that works is A. So now, does there appear to be a difference in the speed? So there does appear to be a difference, right? I mean, we have the median is definitely bigger for the on and the off. Now, if I had picked maybe C over here, then those appear to be pretty close. Again, sometimes it's like reading tea leaves, and it's hard to know when they say appear to be different. You know, what's your gut tell you? Does there appear to be a difference? Yes. The meters on appears to have higher speeds. Are there any? So I had selected that box on the StatCrunch to identify outliers, and it didn't identify any outliers. So there don't appear to be any outliers here. So here's the question. Are the ramp meters effective in maintaining a higher speed on the freeway? Use the 0.1 level of significance. State the null and alternative hypothesis. So the null is that there is no difference. So this is always equal. So the only two where that comes up are B and D. And it says, are they effective at maintaining a higher speed? So this is that if it's on, it would be greater, the mean speed would be greater than if it were off. So that is B. Now we're actually going to run the test. So I can go back to my data. Now in reality, even if it doesn't ask you to do box plots, in practice we almost always do some sort of visual before we start running tests. We need to really make sure that we can run the test. We only have 15 in each, so we need to sort of test for normality and things like that. So I'm going to go ahead and run stat. I have tstat, and I have toSample, and this time I have the raw data, don't I? I'm not giving summary statistics. So raw data. So the ramp meters on are in sample 1, off in sample 2. And I'm testing that mu1 is greater than mu2, and press compute. So there's our p-value, 0.037. Now, again, for your problem, your p-value will most likely be different. You're given different samples. Your alpha level may be 0.01 and maybe 0.05. I mean, so don't just do a carbon copy of what I'm doing. And that's why I'm able to do these videos and feel that I'm not just giving you everything, right? Choose the correct conclusion. So in this case, I've got a fairly low p-value, particularly compared to alpha. So alpha was at 0.1. I was willing to risk a little bit of type 2 error here of rejecting HO when I shouldn't have rejected it. But I am going to reject HO, right? There is enough evidence to conclude at the 0.1 level of significance that the ramp meters are effective in maintaining higher speeds. Okay, so I hope that helps.